in cyberspace. No one is free until we are all free. Self-sovereign, self-sovereign. Privacy is not secrecy. It is a fundamental right. Your life is as private as you want it to be. Second enlightenment. Second enlightenment. Declaring independence from this dying order. Liberty, security, privacy. We will stop only when anybody, anywhere can experience it. No one is an island. We are all pieces of the man. Self-sovereign in cyberspace. No one is free until we are all free. Self-sovereign, virtual territories. Privacy preserving, politically neutral. Borderless, public institution, voluntary consent, resilient parallel societies, maximize the cost of surveillance, minimize the cost of exit. Trust, minimize corruption, resistant, undeserved citizens. Decentralized, decentralized.
Welcome, everyone. To the Logos Dev Club. Thank you for joining. Happy Monday, February 23rd. We are less than 2 weeks away from Parallel Society, Lisbon, March 6th and 7th. A technical unconference on day 1 and a music festival on day 2. If you find yourself in or near the Iberian Peninsula, I suggest you go immediately to ps.logos.co. Tickets are available right now. PS, as in Parallel Society, .logos.co. Procure your passes right away. If you have not yet, logos.co/take action, as you can see it floating across your screen from right to left. Sign up for updates there. Be the first to know when there is something to know. And there's quite a bit to know. And there's quite a bit coming. Logos.co/take action is your destination. On today's show, I will be replaying one very recent broadcast and one from Buenos Aires just a few months ago. First, we'll get the Logos team updates from the Logos core team and the Anon Comms team, respectively. Following that, we'll be showing the talk that Jared Hope presented in November in Buenos Aires. Web3 Privacy Now event covering cryptarchia and blend to protocols featured in the Logos blockchain. Lots happening in the Logos ecosystem. If you are a developer, if you are a technical contributor, if you aspire to be a technical contributor, then I suggest you visit roadmap.logos.co. That is your most direct path to get to the information that is needed for you to begin contributing. There's an absolutely massive effort underway currently to update documentation and the developer journeys for those looking to contribute and implement Logos tech. As things come together, my suggestion is sign up at logos.co/take action. Visit roadmap.logos.co. And from there, you can choose your path. towards the roadmap. There's your URL towards the roadmap. When you land at the roadmap, there are a few sections you can visit. Let's go there together now, shall we? You can see the roadmap.logos.co URL there. That is how you get to the roadmap site. It is constantly and continuously updated. In this reports section, you can find the weekly reports, the past few weeks of these, as these have been coming together. If you are coming in more or less blind to what is happening, this and these reports are the most pertinent. It covers the highlights each week for each protocol. And you can see there is quite a bit happening, and you can find links to the GitHub for each mentioned update. If you'd like to get more granular than that, each component has its own section with its own set of reports. Each week, those reports are summarized in that report section. But if you are particularly interested in, for example, the messaging protocol, you can find the weekly progress updates. You can find the roadmap overview, and within those overviews, the links to all of the relevant places and GitHubs. roadmap.logos.co. Wherever you might be watching, the chat works. If you have any questions or feedback, please use the chat. I can see it. I'll be coming back in between these replays, so know that I am close. First up, we will look at the team updates from Anon Comms, led by Hano, and Logos Core, led by Yuri. The session was hosted by the venerable and brave Corey Petty. I will see you on the other side of this broadcast, and we'll follow up with Jared Hope's presentation from Buenos Aires this past November. Once again, logos.co/takeaction, roadmap.logos.co. Get your tickets to Parallel Society at ps.logos.co. And if you're having trouble remembering any of that, logos.co, most simply, is where you should go. There are links to all the places from there. We are rapidly approaching Logos Testnet v0.1. Currently, we are in a DevNet phase. You could not be here at a better time, in a better place. As things are coming together. The train is leaving the station, but it's not too late to jump in a car. All right, as we boldly move forward, I implore you once again, use the chat if you have questions. I assure you, there are answers. and I'll do my best to provide them to you. This is the Logos team update from the Anon comms and Logos core teams, respectively. I might jump in here or there if I find something to bloviate on as these updates come through. Otherwise, thank you for being here, and let's get going.
Hello, everyone. We do not have introductory music today. We're starting off this kind of three-part series of team updates from all the Logos engineering teams in the effort of making sure that when we get to the all hands in like a week, we're all going to be on the same page, and that we're not spending that precious day all just listening to updates and getting tired when we're all together. So us being together is really important. It's a precious time. So I'm trying to front load as much of that work as we can so that you can all watch these things before we get there. We're all on the same page and we spend that time together wisely. So up first, we have we're going to do this in like kind of in the diagram of the stack, where we're going to start at the bottom with Logos kernel and Logos core with Yuri, move up and have anonymous communications with Hano, and then tomorrow we'll do the blockchain team, which is both the kind of the core piece with consensus, and then the execution environments with LEE or LEZ. And then after that, on Wednesday, we will do Logos storage and Logos messaging. So up first, we're going to go with Yuri. He's going to do a presentation on Logos core and everything that he's been working on, and then we'll move on with Hano. Take it away.
All right, so you can see this then?
Yeah, all good.
Okay, great. All right, welcome to the presentation on Logos core. I'm going to talk about different components we have been working on for the developer journey, and at the end show a quick demo of the app we got. And well, the CCs have been developing modules and apps for Logos core, and we learned a lot from that. And there are some changes we have done to come up with better tooling and a better developer experience. So when external CCs start to develop this, we have a better experience waiting for them. And you should also see in this presentation not just where we are, but where we are going with this. So first, the first step in this pipeline is the build part itself. So the issue that we faced was that, and it's still currently the case, that there's a lot of configuration files needed. It gets a bit messy, a lot of the make files and next files, and a lot of things that have to happen under the hood. And this led to some inconsistency between the projects. For example, some would have code generation, others would not. And this would lead to some things not working as expected, different conventions, and so on. So we built this Logos module builder to simplify all this. And you can see here the results. This is from running in one of the modules. It essentially removes all the next files, or most of them anyway. It massively simplifies the CMake to just a few lines, and also simplifies the flake massively. So it does everything under the hood, essentially everything that's actually specific to Logos. And the idea that this way the developer only needs to worry about their specific dependencies or some library if they are using it. And we achieve this by essentially referring the Logos module as the main input, and then it takes care of everything else. We need a configuration file, specify some things, and that's about it. So this has multiple advantages. So it makes the development process far easier than currently. And it also has advantage that if we update the technology that we use, everything should work the same for the module. The developer does not need to change anything. They don't have to really worry about that. Everything should just work. So we automatically got got the changes in all the modules at once. And there's a command that we can use to build, basically create a new logos module that uses this, because it provides like a template. And there's also skills. So I mean, here I mean AI skills to also create new modules and update existing ones. The skill to update existing modules is quite handy, actually. It does a pretty good job. And we're currently trying to update different modules, see if there's any issues come up. And when there are, we update the logos module builder. So next time it handles that. And it's in a pretty good state. So right now, not most modules are actually not using this. It's something we plan to update after the all hands. And next, there's the logos module itself. And this is essentially an abstraction. There's this common misunderstanding that we are doing Qt plugins or using Qt, but that's not the right way to think about it. What we're doing is a logos module that just happens at the moment to be implemented in Qt. And this might or might not be the case in the future. But from the developer perspective, they're creating a logos module. They shouldn't really care about the underlying implementation. They just care that they're doing a logos module that has particular properties, and it works in a particular way within the context of logos core. So we introduced this library to make this abstraction clearer, and we're in the process of upgrading things. So right now it's a bit in between states. So a lot of things is referring to Qt directly, some of it to logos module, but the intention is to upgrade all of this to logos module. And so then later, if we do update the plugin implementation from Qt to something else, there's no changes also required from any developer, a module developer. And there's a library. You can see example here. The library might look like. So for instance, right now to load a logos module is pretty much directly as a Qt plugin. You have to really put Qt plugin loader, define it as a Qt object, and with logos module, you just pretty much say logos module load this, and it's nothing to do with Qt. And this also allows us to simplify a lot of code for things that are common to do, such as taking advantage of reflection. This is all things that can be simplified. We also provide a command line, so we can load the module and see metadata, see its methods, interact with it. And this also then leads us to the API or the SDK. So this allows us to provide an API that is consistent across all platforms, and we aim to apply this kind of pattern that you say logos dot, you refer to the module name, then you refer to a method, and then pass like whatever parameters. And you can see this in different languages is generally very similar. So the init is kind of slightly different just because of how different languages do things, but it's still pretty similar. So this examples of JavaScript, NIM, and C++. We actually also have for Rust, although it's not shown here. And again, you can see the same pattern API that's in different platforms. It's pretty much the same. That logos dot the module name dot the method, and then the parameters. And they do look very similar. Slight difference due to language syntax and the way it's implemented. So in JavaScript, it can be done it's done at runtime. NIM is currently done with macros, and C++. We're doing that with code generation to achieve this syntax. And the same thing with events, that we provide an event system. So the developer again consistently has particular event names that they can rely on, and a consistent way to do these things. And a couple of town halls back, I made some quick demos of this using the SDKs to take the chat module and use it in an Electron app. Take that chat module, use it on a terminal chat app, and take again that chat module and use it inside the Logos app with completely different technologies. Yet the base module was the same. So this is something we aim to achieve, that we can take our technology and make it very very easy for anyone to use it in any platform without having to worry about these details. Now that we have the module, we need a way to distribute it, and we have for that the Logos package, which we call it LGX. So it's essentially a tar.gz file. It has a manifest. It has a variants for each platform. Those variants can contain multiple files. They generally have a main file. There's other functionality to add to this, such as digital signatures to ensure integrity of all of these. And we provide a command line to interact with these, which can be useful for developers when building these packages. And we need then a way to distribute these packages. So we have a package manager. And we built this LG PM. So it's a tool to allow then listing and searching and installing these modules. And we provide again as a command line and as a library. So this is generally a pattern we also aim for, to make things available as both libraries and command line, just for maximum flexibility there. And at this stage, because it's a proof of concept, we are publishing and downloading the packages from GitHub. And you can check this at the Logos modules repo. You can see the releases, and you can find all the modules there. And that's where the package manager is getting the packages on right now. And but this is intended to fetch and download packages from a decentralized system. So that will be the next stage, would be to implement such a system. And now finally, we got the execution phase. So, and that's where liblogos comes in. And liblogos runs each of the modules in an isolated manner for security reasons and also stability. This currently means they run in the same process, but this can be done. But later, quite possible that like modules will run them in containers or even in different machines, and yet they can all talk to each other. The graph is a bit misleading because it looks like they all talk to only Logos core, but they actually can talk to each other directly, and they do. But the core ensures that they have permissions to talk to the right one, and that a module is not talking to another one that they are not they're not authorized to. So you might have a logo, same module that you authorized to talk, say, to your wallet, but you don't necessarily want all modules to talk to your wallet. So the core ensures there are some permissions there. And the core also manages then orchestration, so you can have these modules run in different machines if needed. And yet from the user perspective and from the developer perspective, that's all abstracted. Like when you are developing a module, you might say, hey, I want to send this message to this module, but it's completely irrelevant to you if it's running in the same process, if it's running in a different machine. It doesn't matter. You use the same API for everything, and then the core actually takes care of getting the messages across. Then finally, we have the execution. And the execution is, liblogos is very versatile, and we have 3 ways to execute all of these. One is that the developer can just do a dedicated app to whatever they're doing. So they can take the SDK that uses lib logos, and they can use whatever language they want, and they can just code a dedicated app to a particular combination of modules. The second is that they can run the logos core command line in a headless way to execute one or multiple modules. And the third way is that they can use the logos the super app. So the headless, this is how it works currently, that you can pass a folder that contains the different modules. You can choose which ones to load. And this load modules would also automatically take care of loading any of the dependencies that a module might have. So if, for example, if you load the chat module, we'll automatically load the Waku module, because that's a dependency of the chat module. And then it can pass the specific methods that you wanna call, including passing configuration files if you want to. And that is to run headless, to run in a server or locally or Raspberry Pi or whatever you want to run it. Then we have, for the end user, we have the Logos app, which you're calling it Logos Basecamp. And I think it's quote here from Jared that Logos Parallel Society, Logos Basecamp is the interface to it. And this includes, so it has a package manager included as a pre-included app. And we have other apps as well at launch. I will not demo those apps because I think each team is gonna demo them. But we have the wallet, chat, storage, accounts, and others. And I can present now here the app. I just need to change the present to show only the app, because otherwise we have issues with the Zoom. With the resolution. Okay, so share Logos app, and I'm gonna assume that you guys can see this.
Yep, all good.
All right, so we are here. So this is the current app we got. So we do actually have the icons. I gotta say, we have this working. All the icons looks even prettier than this, but we have a last minute technical issue. But it's all there. Like it does work with those icons. So I can see this works as an interface to Logos Core, so you can see the logos that are currently loaded. What are the CPU usage, memory? So I can see Waku module using, I don't know, 100 losing a lot of CPU, I guess, because it's right now running as a full node. And I can then say go to chat, and I can send messages in the chat. I can go to, say there's an account here that this is and the wallet. This is using the Go Wallet SDK, and we do have then the package manager, and the package manager can install things. So, for example, I can go here to Logos REC module to install, and that installs. In this case, it's not an app, so I can go here and then load it. And yeah, so that's a quick demo, and as I understand, other teams will be presenting their apps, so I'll not be demoing them here. And yeah, that's it.
Quite the progress there, Yuri.
Indeed. Thanks.
I like your presentation style. The slides look good. All right, Daniel will be here. We can take questions at the end, but for now we can move on with Hano and do anonymous communications. Thanks, Yuri. Take it away, Hano.
Awesome. Let me just get this started. Yes, I will be giving an update on what the non-comms team has been doing. And I'm also using this opportunity to just introduce people to the non-comms team if they don't know the team. I think after the reorg, many of the teams sort of mapped to a team that was there before, but the non-comms is one of the new teams. And I also had a little bit of a chuckle at this snippet from what we wrote on our officially published roadmap, which is to say the non-comms team is the team that does anonymous communication, which is exactly not helpful at all. So I hope to hereby make amends. I think a useful thing to keep in mind, so this is a kind of a sub-team structure or more or less a division of the tracks in which we work, right? No one really works just within one of these tracks. There's always a bit of overlap. But think of a non-comms as sort of a merger between what used to be the ACZ team under VAC and the WACU research teams. Many of the tracks that we are working on are just a continuation. We also collaborated even before the reorg on many of these tracks, and now it's just consolidated against the Logos launch strategy. I also want to take a leaf out of Frank's book. He likes to give a methodology as part of these updates and kind of just explain what the philosophy is according to which we work within the team. This also really, I think, illuminates sort of the update that's about to follow based on these principles. So I think for a research-based team to say that protocols are products are very important. So practically that means that our specifications themselves are seen as first-class deliverables. I do promise that I'm trying to avoid acronyms in this presentation as much as possible. You won't believe me in a few minutes, but I really did try. One, to remember your LIPs. So if you don't know about them yet, these are the Logos improvement proposals. When you see this, just think of this as specifications. Of course, within the Logos environment, modularity and reuse is super important. So you will hear me say a lot of things like API and interface. Of course, in a world where we want to have modular components, your API specification and your interfaces become the way in which you communicate about the modules and the protocols that you develop and how those can be integrated within various stacks and applications. As a team, we built early POCs. So in some cases, these POCs are even the kind of point at which we hand over an implementation to another team to do a full implementation. So we'll do the set of specifications, a POC implementation, and then hand over to another team for full implementation. But this allows us to basically get very fast feedback on how well a protocol works. This feeds back to the protocol itself, changes to the protocol are made, and then this iterative loop really helps to mature ideas and implementations. In some cases where we hand over implementation, we'll continue to act as a type of red team to battle test that implementation. Where we own implementations in other tracks, we like to dock with these as soon as possible. People are very often interested in what languages we use, so NUM and Rust, depending on which track. And yes, so I will be going through the tracks of a non-comms, and I'll answer these 3 questions for each track, which is what is it that we do within this track? What are we building? Why does it matter for Logos? And then we'll just try to summarize what we have done so far and what we see as the next steps. Yeah, and the best place to start is probably capability discovery, because this is the top priority for the team. And I find here that the best way to explain what it is to just briefly sketch the problem. So within any kind of peer-to-peer topology, the first thing that a peer that joins that network needs to do is to find other peers to connect to, right? This is the process of discovery within Logos. Of course, we want this discovery method itself to be decentralized. If you have a centralized way of discovering peers, you can very easily take down the whole network by just attacking this centralized point of discovery. And luckily, there already exists decentralized discovery protocols, right? Most of these are based on DHTs. And you don't need to know the technical details there, but in general, this allows you to find a random groups of peers that participate within this specific peer-to-peer topology. These protocols don't currently allow us to have an efficient way to discover peers that support specific capabilities. This is to say peers that support the kind of protocols that's necessary for your application, right? So if you have a peer with a specific set of applications that you want to deploy, and you are interested in a very specific type of service that you need to find nodes for, the best you can do is basically grab a whole bunch of random peers that participate in this topology, and you hope that the ones that you are interested in are somehow part of this random group. And if you have a very specific type of peer that you're looking for, this can be like looking for a needle in a haystack. So this is famously called the needle in a haystack problem for discovery. And the more heterogeneous your environment, the more difficult this becomes, right? The more specialized services that you try to find. So in this track, Anoncoms is focusing on developing the protocols to develop an efficient capability discovery mechanism, a decentralized capability discovery mechanism. Okay, and I think it could be quite obvious why this matters for Logos, right? I mean, this is a very critical cornerstone. This is why it's the highest priority. If we speak about Logos, we speak about an extremely heterogeneous environment with all these different kinds of modules and applications and different stacks. They each need to find the peers that matters for that application to work properly, and you need an efficient way to do that without sort of losing the integrity of the system. At the same time, we're also building this as a general discovery module, right, that can be incorporated into any Logos app. We'll be doing many integrations, but there will also be the ability to just integrate this module yourself for any app that you want to write. What have we done so far? So we have 3 new specifications published here. So the first is one introducing a way to encode capabilities within the peer-to-peer signed peer records. The second is a way to introduce filtering based on capability within CAD-DHT discovery. This is just one of the discovery methods that already exists. This is also, by the way, fully implemented and is even part of our demo app that you can use for the testnet. And then we have the full capability discovery protocol. So this previous one is just a sort of intermediate step, but we are working towards this full capability discovery protocol. This is now published. There's an API published for that, and we have all but finished the POC implementation for that. For those interested, where it kind of comes from, this is mostly us adapting a paper that was published by, I think, EF researchers called DiskNG Service Discovery. Again, I apologize for acronyms. This one is not ours, and it does stand for Discovery Next Generation. And yeah, we'll continue to work on kind of helping get this implementation to kind of a full maturity. This is one of the examples where we will function as a kind of red team and hand over the full implementation to the peer-to-peer team that wraps this within their peer-to-peer module with discovery. But we're also working on wider integration into the Logos chat app, Logos delivery as kind of first steps. I would say benchmarking will be very important in this track. We know that capability discovery, this new protocol, will greatly improve efficiency of discovery, but answering the question, is it good enough? That requires quite a large-scale simulations and understanding. We'll collaborate with teams like TST here. Discovery itself at the kind of protocol level is not anonymous, so we will also be introducing ways to anonymize these interactions. Yeah, and speaking of anonymity, the mix track, this is where the bulk of the anon part of Anoncoms is taking place currently. So because this is where we are developing all of the tools to anonymize communications on the routing level. And I really mean this is the sort of infrastructure level of the peer-to-peer connectivity. Practically what that means is we're developing the peer-to-peer mix protocols. And this is plural here because it's actually a whole bunch of different interacting features that can provide a whole set of modular anonymity features. And at the same time, we're combining these into one or more mix layers for Logos communications. If the word mix is sort of new to you and you don't quite know what it is, conceptually think of it as a way to introduce infrastructure layer routing anonymity by mixing the packets of communication in the network into a large anonymity pool, sending them over multiple hops, introducing random delays and things, so that eventually all of the traffic looks exactly the same. And there's no way to correlate where messages are coming from, where they are going to, what applications they belong to. Large part of the LibTB protocol was already developed before the consolidated the non-coms effort. So one of the first challenges we addressed as the non-coms team was to design a way to protect the mix layer itself against DOS and Sybil attacks. So we've developed a pluggable mechanism here based on RLN. It has to be pluggable because we want this to be useful and for other applications to set up their own mix layers, but maybe based on a different set of authentication rules to protect it. It matters for logos, I think, because this is core to our ethos, right? You can't really have sovereign communities if your infrastructure itself does not provide the kind of privacy preservation that is core to setting up these communities. And we have the existing integrations already for logos chat and delivery. We are working closely together with Logos Storage. I have to say, for me personally, this has been a very fruitful collaboration, and the storage researchers has been really great in coming in to this effort as well, and we're working to use with them to use Mix to anonymize various parts of file sharing. What we have here, we have the Mix spec and implementation that's ready. We have this pluggable mechanism to protect the mix layer with RLN. The spec is ready and there's a POC implementation. Mix has been integrated into Logos delivery. For those who don't know this name, this is sort of the new name for what used to be the WAKU module. And yes, there's a demo chat app, which you can already test it, but it will be part of the upcoming Logos testnet, where you can use Mix to publish messages anonymously. I should also mention this demo chat app demonstrates the capability discovery API as well. This is how the Mix network is formed. And yeah, next steps, this collaboration with storage is ongoing to kind of also introduce this as one of the ways in which file sharing can be anonymized. And as I say, Mix is a whole set of anonymity features, and features that are upcoming would be things like long-lived Mix circuits, generating cover traffic to increase anonymity. Provider anonymity is maybe a bit technical, but it's also coming. And then, yeah, we need multiple Mix layers for different types of applications, needs a different set of anonymity features to be most effective for that application. And we want to introduce those. Service incentivization is perhaps a bit of a misnomer for this track because it's more a general incentivization track now. But yeah, this is a continuation of an old WAKU research track. This is where we are developing privacy-preserving payment protocol. And indeed, for the first aim is to use that to incentivize decentralized service provision. And when I speak about services here, I'm really referring to, at least for now, the kind of infrastructure-based services that we all know, we rely on and maybe rely on a little bit too much for our infrastructures, right? Things that are often provided by fleet nodes. Serving historical messages, kind of like being storage providers, providing a way to publish a point of publishing anonymously into the network, these kind of things. And our first step here is to develop a mostly off-chain protocol, but kind of backed by an on-chain privacy-preserving payment stream as sort of the rail, the on-chain rail on LEZ. Why it matters? Well, I think we know that robust infrastructure would be decentralized infrastructure. I think especially if we look at mobile adoption, perhaps growing a kind of a larger focus on mobile eventually for Logos, this will become even more important because then there's a higher reliance on service infrastructure. And this is one way in which we can incentivize the decentralization of services. to avoid all of these problems like single points of failures, censorship, and more. And of course, I think from a principal perspective, community members need to be able to provide or participate in service provision and probably be compensated for that as well. But this payment protocol we're developing is also pluggable for general incentivization use cases. And I think there's a good amount of conversations on how LEZ can be applied for these kind of real-world payment use cases. I think if you visit the VAC forum now, there's good conversation about how payment streams could be translated to LEZ as well. What we have here, we have the raw spec, the lib for the off-chain part of the protocol. Go read that and comment if you want. And we are working kind of collaborating with various teams, well, blockchain, more the LEE sub-team in blockchain and other teams about the challenges to implement payment streams in LEZ environment. And we want to demonstrate how this practically work, first of all, within the Waku Store protocol, but also extrapolating from there. Then we have the DMLS track. So DMLS is where we are building the decentralized version of messaging layer security, or MLS. So MLS is kind of the industry's standard protocol for achieving secure group messaging. It has a lot of very, very nice features to achieve this group messaging protocol. But it introduces, or it contains two very centralized parts in the protocol. One is around how messages are delivered between members of the group. The other one is around group authentication, key distribution, making sure everyone knows which key to use to publish messages. And we are in this track addressing these points of centralization within MLS. Message delivery, it could be quite simple, right? You just plug in something like Logos delivery, X Waku for message delivery. But when it comes to authentication and key agreement, we're building a new off-chain consensus protocol. There's group voting. There's all kinds of dispute resolution mechanisms that's being built. And yes, it matters for Logos because this would most likely be the first fully decentralized protocol for group messaging that has all of the wonderful features of MLS, right? And yeah, this will even be or is already actually a pluggable module that anyone can use for their decentralized group communication use case. And you can imagine if you're a sovereign community that the communication part between members of the community is extremely important. We're also integrating it, of course, into our own Logos chat module. This is how group chats will work. And yes, we now have DMLS specified. We have a Rust implementation. The API is also published. There's also an API specification. Yeah, so you can already use DMLS. This also includes a sort of sub-module that we've developed to achieve off-chain consensus. This is a separate protocol with a separable module there as well. So that part can also be reused. And because this API is now ready, we are working with the Logos chat team to start integrating it into the chat stack for group messages. And there are some more advanced features that we are also implementing now. Yeah, multi-stewards group rethinking. Do engage with the ACZ team if you're interested in these things. Rate limiting nullifiers. So I think, again, to everyone's relief, I won't actually be explaining what rate limiting nullifiers are, but I will just say what we do in this track. And this is the track in which we want to do general RLN research and development of protocols. This is the newest addition in terms of tracks to non-coms, born out of the fact that we noticed that RLN is being used now quite fundamentally in a wide variety of Logos use cases. And there are some general RLN problems that requires sort of dedicated attention. For now, we only have one contributor working here, so we only have the first milestone is mostly about addressing specific bottleneck to RLN adoption. And this is around obtaining your RLN membership. So for RLN, you need a kind of on-chain membership, which requires an on-chain transaction before you can use an RLN-backed service. And we've seen that this is the major hurdle to adoption of RLN. Even if you make this free, it's a psychological hurdle to get across. So we're developing a membership allocation protocol, which will be a service module that can be published as well. This will allow you to distribute RLN memberships based on some kind of pluggable authentication mechanism. And in the process, we're also porting RLN from an EVM-based environment to LEZ. This, I think, has been very interesting. And it matters for loggers because RLN is essential already for loggers chat. It is now the way in which we will protect the mix layer against DOS and Sybil attacks. But we're also envisioning RLN to have many future applications. I think within last week, researchers from the EF published the proposal on how to use RLN to achieve some payment mechanism for APIs. But in the medium term, we want at least loggers modules that require RLN memberships, right, for each of their different maybe chat applications for mix layer, to be able to get sufficient memberships for for what they need. This could even potentially be free, and all without requiring each of these users of the modules to do an on-chain transaction, but to rather use some kind of pluggable authentication and then get a distributed membership. This is also, as far as I know, at least the first Merkle tree implementation on LEZ, which I think is great for the environment. But longer term, this is going to become the general RLN track. So there's a bunch of things lined up already in terms of proof generation, in terms of slashing, improving user experience even more, and as I mentioned, expanding applications. This will fall in this track. What we have now, you can go read our raw specification for the membership allocation protocol. Well, this is work in progress with this pluggable authentication mechanism. We are collaborating on implementing RLN within LEZ. I think much of the value so far in this track has been this conversation. I think lots of subteams collaborated here, and again, storage researchers helped with the improvement of Poseidon hash generation in LEZ. So I think great progress there. And yes, we want to wrap this up and also have the RLN roadmap take shape in general. Then we have this track, gasless transactions. So in this track, the Anoncoms team is more of a service unit to help the status L2 effort of having free transactions on status L2 based on reputation, right? Reputation measured by some balance in karma. And this mechanism is based on RLN. So we are developing the RLN tools that's necessary to support this, specifically an RLN prover module. But it matters, I think, outside of just the status L2 effort as well. For one thing I'm quite excited about is this improved RLN flexibility. So as part of this effort, we're adding a way to burn multiple message IDs in a single RLN proof. If those are just words to you, it just means that RLN can probably be shifted now from just having general rate limiting as its only kind of avenue of protection to something more precise in terms of quota limiting, right? Which gives you a more precise tool. So instead of saying, I allocate this number of messages per second to you, you can do something like, say, you have this amount of bandwidth available. So yeah, I don't even think we've fully realized the potential of this improvement for RLN. And we're developing a reusable RLN prover module that is kind of a way to offload all of the RLN proving functionality and testing RLN for a whole bunch of use cases that it's not been tested for before, including high-rate use cases. And yes, so far we have the spec and implementation ready for the RLN prover module. There's a draft white paper on this whole mechanism on achieving gasless L2 transactions with RLN, which I encourage people to read. We are also planning to submit this for the ASBC conference. I don't know what that stands for, but I think that's a nice thing to go and read. And we'll continue adding more advanced features here. We also want to eventually allow local proof generation from the wallet with some kind of ZeroKit backed way of doing this. And if your question is what is ZeroKit, you're in luck. ZeroKit is our Rust-based collection of zero-knowledge modules specifically for RLN, right? So we are the maintainers of this library. And this is the foundational library for all of the RLN integrations that we have across Logos. So we have an API here in Rust, we have FFI in C and WASM, and this is where RLN core is happening. It explains also why it's important for Logos. It's the integrated in all of our RLN implementations. But I think this is also by itself a very powerful library that can be distributed to anyone that's interested in experimenting with RLN, right? So it could be a module itself. Progress so far is we've just finished the major API rework here. It's all much simplified now. There's a new API spec, which you can read. I would actually encourage people to go experiment with this. I think it's quite powerful. And of course, the work that's coming up here are the works related to RLN itself. So this is mostly implemented within ZeroKit. So again, based on storage research suggestion, we've working on a way to improve how RLN proofs are generated. I think we had almost 300% improvement in generation time. We're working on this multi-ID burning feature. This is the feature that provides the RLN flexibility that I mentioned. So all of this is upcoming within ZeroKit. And if I remember correctly, that's it. If you scan this QR code, you should be going to our landing page on the Logos roadmap. And that's it from my side.
That's it? Nothing else? That's not a lot.
I can keep talking, by the way. Yeah.
Thanks, Hanno. So we got everyone here. Yuri and Daniel are brought up. If you weren't paying attention, your screen's a different thing. You're now on screen, Yuri and Daniel. If there's any questions, feel free to ask them in the chat and we'll handle them live. If not, throw them in, I don't know, some channel in Discord and then ping me so I can get them answered ahead of time. Is there anything else, Daniel or Yuri, you want to add to that? Or something else you'd like to say that's relevant? Yuri's pleased. KSR's pleased.
So nothing to add from my side. Yeah, just thank you for the presentations, and we'll have an overview then at the offsite across the test nets. But yeah, that will be part of the offsite agenda. Let's go to questions.
To have the agenda published by the end of the week, at least. So that way everyone kind of a general idea on what the flow of the day before the PS event will be. Giuliano has a question for Yuri. Will we have a skeleton generator like we have for modules for Logos apps too? Or maybe some compact documentation, small example I can refer to?
Yeah, we will have that. We'll focus first on the pure Logos modules. That will be the first focus, and after that, we'll do something for the apps themselves.
I saw Andrea shipped me a demo that he had who's from the smart contracts team, which are building apps for Logos. He had built basically like a demo of what would be the equivalent for a Foundry for Logos. Is that something you think will expand to be like what Giuliano's asking about, or what do you think?
I believe there are different things. So unless I misunderstood Giuliano, I think is referring to when building Logos apps themselves, the UI part. If there is going to be a generator and a template for that. just like we're doing now for the Logos modules themselves.
Okay.
And
Yeah, and then
that's-
so
yeah.
So just adding to the Foundry, this is more for deploying stuff on Lee, and then we will have a scaffolding developed by EcoDev, and that will in turn use Juris components. So it's kind of a layer on top of that. That is planned. We plan to do this after testnet v01, and also definitely get better documentation how to how to write modules and apps. And with both that automation and the scaffolding plus the documentation should be much easier to write modules.
So as a heads up, Frank was hoping to be a part of the last town hall, but we couldn't make it. So right now he's doing a video that will distribute alongside these of like what the efforts of EcoDev are, which probably include some of that scaffolding that you're referring to.
Yes, and we definitely from the Logos R&D side, we need to provide better documentation. The things like Frank, I just had a call with Frank before, and EcoDev will, for now, they will focus on deploying contracts on Lee, because that is something we can already test, and we need that for the external labs. And for the scaffolding, they're waiting on getting better documentation, because it makes sense for them to red team the documentation and not getting primed by us on how to do that stuff. Because if we do this and then they read the documentation, they already have prior knowledge and might not be able to red team it as well. But that will happen after the offsite.
All right.
Yeah.
I don't see any other questions here. Thanks, Giuliano, for speaking up. Tomorrow we have the blockchain team going, so that's going to be both the Mantle and the execution zones, well, LEE/LEZ and Logos blockchain. That'll take up the hour, and then the day after, which is Wednesday, we'll do storage and messaging, and that should wrap up all of the engineering teams for kind of status updates on where we are and what's planned, which allows us to be all on the same page when we get to Lisbon for the all hands. Very much looking forward to it all. If you need something or want something or don't know something about what's going to happen at the all hands, please message me now. And it's all pretty wrapped up at this point, but like maybe I can fit something in, change something, ensure that whatever you need is included. And remember, at the end of the event, and even during the event, the festival part, we have all of the room for offsites. So it's like focused work. So all hands event, focused work afterwards. So looking forward to it. And that's it. I'll see you tomorrow.
And there it is, folks. That was team updates from the Anoncomms team and Hano, the Logos Core team, and Yuri. As you are well aware, after watching that 50-minute presentation or so of just 2 of the 5 components that exist in the greater Logos stack, a few takeaways that dawned on me. Number 1, and this should be your number 1 takeaway at this point. There is no open source team in the blockchain space or beyond that is more stacked and that has contributed more to predecessor blockchain projects a la Bitcoin and Ethereum than the Logos Core team. There is an abundance of talent across all of the protocols, and there is a ton going on. Much, much more than I could possibly cover in one of these sessions. The onus is on you to visit roadmap.logos.co And if it was a non-comms that was the most interesting to you, you can find all of the pertinent paths there. If it was Logos Core, same thing applies. There are a litany of accounts. You're watching this broadcast on one of them, wherever the destination is. Those destinations, by the way, do not deserve me mentioning their names, and shame on them. Shame on them. And you should know why. But wherever you are watching, there are a litany of accounts to find. Logos_network, Logos_devs on X. Logos Network, all one word, on YouTube. Seek them out, subscribe to them, follow them, turn notifications on, go to logos.co/takeaction, sign up for updates there if you are a developer, roadmap.logos.co. I would put up the Logos core contributor roster, talent and contribution wise, up against any and all other blockchain teams. That includes the Ethereum Foundation and the core devs. That includes Bitcoin Core. That includes whatever the heck is going on Sui. I don't know. I can't even fully confirm that that's a real thing. But Logos Core is very real. There is an abundance of talent that is unmatched, period, in the crypto and blockchain space. And as a lot of foundations and teams of core developers pay massive lip service towards privacy over the past 6 months or so, the Logos core team has been shipping and delivering, researching and delivering the actual protocols, RLN, rate limiting nullifiers, being one of them. And it's a great example, as Hano went into it in depth, what's going on with RLN, where it has come from and where it is going. And well, all of a sudden, there's other foundations that have picked up interest in the work, the foundation. That was not 15 minutes. Syndrome, when did I say it was going to be 15 minutes? Give me the timestamp of when I said it was going to be 15 minutes. It takes 15 minutes to tie your shoes if you're doing it correctly. That is Syndrome in the chat. If you, by the way, active and good community member, Syndrome. By the way, and I just mention it briefly, Syndrome asked me the other day on another broadcast whether or not Keycard Shell and Keycard will be available at Parallel Society, which I know Syndrome is planning to be there. Not to dox you, Syndrome. Dox your location. However, if you are looking to get a Keycard Shell in your hands, it's probably wise to order it and not wait. Tariffs being what they are, I understand. However, to ensure that you can get a Keycard Shell, the world's first and only 100% open source, 100% air-gapped hardware wallet, order at keycard.tech. Okay, we are shifting gears now to a talk that the founder of Logos, Jared Hope, gave at Buenos Aires in November. It introduces, so we're going backwards now. We went on a slightly lower, more zoomed in level and looked at updates from the Anon Comms team and Logos Core respectively. We're going to zoom up a bit and get the more complete overview of what Logos is building and striving towards from the horse's mouth. I will take you there now. Again, if you have any questions or feedback, please use the chat wherever you might be consuming this. I can see the chat. If you are a developer who is looking to learn more at a lower level, roadmap.logos.co is your portal. You can find definitions of all of the milestones each protocol team is working on or component team is working on. You can find the work across all of the GitHubs, and you can begin contributing to whatever level and ability you can and want to. We shift now to Jared Hope from Buenos Aires, not 3 months ago. This is an introduction to Logos and the future of freedom with Jared Hope. I will see you on the other side of this. Thank you for being here. This is Logos Dev Club. See you soon.
All right, cool. Hi, thank you for making it to the end. I'm sure you're tired. I'm tired, but it's been a fantastic day. I'm here to talk to you about Logos. This is going to be it's kind of a weird talk for me. It's a little bit of a high-level introduction. And I would normally talk about political philosophy or like my internal motivations. If you're not familiar with any of my talks, you know, there's some QR codes to some of those. I think
By the way, it is worth it to scan those QR codes, especially if you'd like to go deeper, as it were. Each of those talks, and you can see that they started in 22, moved into later 2022, 2024. Specifically for me, the corruption KYC and the cost of compliance talk, which I believe I heard Jared give around April 2024. So more or less 2 years ago. And this is of course my interpretation and my synthesis and analysis of the content in that talk. Corruption, KYC, and the cost of compliance. You know, it takes time for things to develop and mature. So as someone makes scientific-based hypotheses and predictions, it takes time for the Earth to rotate around the sun a few times and prove or disprove those hypotheses. There's a whole lot of truth in that one, and there's a whole lot that is relevant to the state of the world, both politically and financially and economically, that were laid out very clearly in that talk. So I do encourage you, if you are interested, bookmark those talks. They're widely available and accessible, but there you are, the QR codes. And specifically corruption, KYC, and the cost of compliance is very, very, very relevant to what is happening geopolitically at this time, as well as the other talks. So dive in. We go back now.
I think for this crowd, like you're already here, so you kind of already internally understand why privacy matters and these sort of things, but you might be interested in corruption, KYC, and the cost of compliance, and how this sort of went hand in hand with the Patriot Act when the 3 towers were demolished. Anyway, so show of hands, who can recognize all of these logos? Okay, all right. Oh, yeah. That's expected. For the rest, that's no surprise. Basically, like, you might be familiar with the onion, Tor. So like on the sides there's Tor and there's the ITP network. The things that look like little bunny rabbits, they are Freenet and Hyphenet, and the one with bullhorns is NuNet, right? And so like these are not like Tor and I2P, you understand probably, like they're anonymizing networks that allow you to basically have censorship-resistant communication while being anonymized and doing so, both in sender and receiver unlinkability. But like Freenet and NuNet were kind of more ambitious than just doing anonymizing networks. They envisioned a civilian internet. They were very concerned about the sort of digital intermediation that is currently happening through all of these sort of big tech platforms they're doing, like this sort of neo-feudalism. And they worked on creating this sort of decentralized technology stack that allows you to publish sites outside of like a typical client-server model. And the middle one there, that's Tribler. Tribler is a BitTorrent client, right? It is fully peer-to-peer. They claim they have one of the fastest peer-to-peer search for that, so you can find content within it. And they use onion routing as well to protect you while you're torrenting. That's a university project out of Delft University in the Netherlands. But like this, all of these projects are effectively like 20 years old, right? And like this idea, like there's so much we can still learn from those that I just don't really see actually happening in the space today. And like we should really be continuing that on. In fact, one of the reasons I fell in love with Ethereum is in like the 2014 vision, there was this sort of like heritage of this, where like there was these primitives where you would actually create a vertically decentralized technology stack where you could actually create real decentralized applications. You know, it has been 20 years, and there's quite a few shortcomings, right? Like imagine how it is to access like your, you know, a popular decentralized application today. The reality is if you're on a desktop and you'll probably use your browser, you'll probably type in a URL and click on something. You'll immediately start using a name service to resolve it. Typically, it's DNS. Then you'll be accessing a client-server model, right? Once you've got your front end from that server over the web, it's most likely going to be using some kind of trusted another client-server model in terms of accessing the crypto network, right? You know, in terms of our public mempools, they've become professionalized and become more centralized. And at least in the, you know, in like the sort of dominant networks that we have today, our accounts are pseudonymous but public, as well as our transactions. Worse is most of these are actually still happening over ClearNet protocols. And while I've said most of those things, you've probably thought of some project or some startup that has identified this as an issue and has been working to resolve it. But we have protocol fragmentation. If you wanted to be a purist today to access a decentralized application, it's incredibly high friction for an end user to do that. They'll probably have to download like an IPFS node. If it's on Ethereum, you're probably downloading both a consensus client and a execution client, unless you're using Nimbus. And then you have to maintain these. And then finally, if you know where you want to go, you can go, access through a CID or content hash. So kind of like the best in the class that we really have today is like some kind of combination of a couple of protocols, right? If we really care about privacy, you're probably thinking about using an anonymizing network like Tor and combining it with your favorite private transaction systems such as like Monero or Zcash. The issue with this is like, well, you know, a general purpose anonymizing network has its own issues. It's, you know, depending on how you parameterize that network, you know, there's different ways you can trade it off. But if you imagine it as an economy or a socio-political system, something like Tor can't really maintain its economy. It needs to rely on something like Monero or Zcash. At the same time, Monero and Zcash don't really inherently protect the network level privacy. I mean, Monero is doing a great job with Dandelion++ now. But then, like, if you still, even if you're using this, if you're accessing an application over Tor, it's still inherently relying on like this sort of client-server model, which is quite a shame because like the author has done Freehaven beforehand, and I'm really waiting for him to get back to it. So the question is this the best we can do, or can we do better? The ideal is basically we need to have network level privacy. We need to have private programmable transactions. Our front ends basically need to be hosted across the entire network and be user verifiable. We need to ensure that you have disintermediated access to these networks and even from consumer-friendly hardware, both in participation of securing the network as well as accessing it from your phone or whatever. Ideally, all of these protocols are integrated in some way, so the friction of actually participating in this network in the way that we envision is done, and of course, it needs to be scalable if we want to have a decent anonymity set. So that's kind of what Logos is trying to aspire towards and what we're building, right? It's not really a new layer, yet another layer one, but it's a private by default decentralized technology stack. While there's many subsystems and many sub-protocols involved, as a developer of a decentralized application, you basically get three major sort of pillars or primitives. So this is anonymous networking and communications, decentralized file storage, as well as private smart contracts. So we can basically, in building such a system, you can split it over these domains of concern. In the interest of time, I'm going to skip it a little bit. And we need a decent foundation to get started with. So we have to start with anonymous communications. We work on a private peer-to-peer messenger / mobile Ethereum client called Status. And over the years, we've learned a lot about anonymous networks. It turns out that depending on the traffic type that you're trying to cover and the sort of trade-offs and properties that you want, there's not like a one-size-fits-all solution. There are issues with onion routing. There are issues with mixed nets. And in our case, there were certainly issues with remailers or flooding gossip subnetworks. So this has led to us creating a sort of framework called libp2p mix, in which we can actually parameterize for different traffic types. So for example, you'll have, I'll give an example a little bit later on. But here, you're thinking of basically a mixnet in one instantiation, but if you need more throughput, you might consider onion routing in certain scenarios. But here we're largely just thinking about sender unlinkability, right? libp2p mix is not a transport in of itself, it's an overlay protocol. And so it actually allows us to basically mixify or however you want to anonymize your sort of standard libp2p protocol. And it's all got the good stuff that you'd be aware of, Sphinx packet routing. We can parameterize in different ways, and we have anti-spam measures as well, which is also pluggable. But this is for nodes that have like decent bandwidth. They probably have less churn rates. Maybe they're participating in consensus. So this is kind of like the core of the network, right? But there's also an issue if you're actually trying to connect to this from a high churn device, such as just your mobile phone. And so we have like another protocol, which was it's been known as WACU, where we essentially have a sort of flooding gossip sub network, and it's largely focused on doing receiver unlinkability, right? So you can kind of choose your level of participation in this network, and there's various other sort of sub-protocols towards this, such as like filtering the kinds of messages you actually care about. If you churn off the network, you log off and you want to come back, you might actually want history, right? And if you're developing a decentralized application, there's certain scenarios in which you might want an ordered log or like the sort of messages you want to send are not really worth putting on more heavier systems. And even though I kind of glossed over that in the interest of time, this is a 30-minute talk compressed into 20 minutes, so I apologize for that. Those two protocols, I also want to highlight just how impactful and transformative they are. And like, if you think about Tor, it has been at the center of some of like the largest sort of revolutions in our modern era, from like the Hong Kong umbrella movement to Arab Springs. And what's interesting about these sort of movements is like they're able to carry capacity. They tend to be like collective emotion. But if there is a chance for change in, say, like regime, very often there isn't any sort of like plan for new governance. And that's where we kind of need to start thinking about a sort of a Lamportian part-time parliamentary sovereignty, or a blockchain, public blockchain. So we provide, or we've been developing a sort of integrated multi-chain network. It's at its core, it's basically a state transition function is risk zero. It has zero cash semantics around it. We've developed out a private proof of stake and a parameterized network for block proposal and linkability. And it's multi-ledger by design because the rate of change in terms of the garbled circuits, MPC, FHE, zero knowledge proofs is changing quite a lot. And we want to be able to have multiple versions of these state transition functions and kind of upgrade or grow with that research. So, the reason why we have risk zero at the base layer, it uses a UTXO model. The UTXOs is a general purpose data model, and then we can use that in terms of for doing various sort of state transitions. But we basically use the root chain as for providing services on top of that. And you're probably familiar with block relay censorship as a result of tornado cache and so on. And we were thinking about this quite a lot, right? So a lot of people have been discussing like the use of mixed nets for this, but there is a bit of a problem with it. Mixed nets effectively get their anonymity through delays. And so if you're using something like consensus traffic, you have to understand the nature of that traffic. And it's basically a bunch of synchronized senders, right? So let's say you had 100, 1,000, 10,000 validators or miners or whatever. They're effectively sending a wall of traffic at regular intervals. It's incredibly deterministic. And if you want to put that through a mixed net, it's going to blow out your delays far beyond what you want in terms of a block production rate. In our case, it's 1/30. And so we had to parameterize libpdbmix to basically create a sort of hybrid between these. It's kind of like a hybrid between a flooding gossip sub and a mixed net. And the reason we have to incentivize and disincentivize the cover traffic as well as the allowable block proposals in a certain period. And the reason for doing that is basically constraining bandwidth. So this is basically, you're using things like packets. You do your routing through those. You're sending out 5 different paths, but through a flooding gossip sub. And it turns out that we are able to minimize the amount of bandwidth, get dispersal as fast as possible in approximately 20 seconds. And we believe under an active adversarial model of roughly 20% active adversary and 10% churn nodes, that we can delay the linkability from a block proposer and their block proposal by about 7 years. So proof of stake, making private proofs of stake. I don't want to start any wars here, but it's probably actually easy to conceptualize this as something like proof of work in terms of it has difficulty adjustments. This is most proof of stake systems require some validator set, like a known validator set and a known total amount at stake, right? In our case, we are able to get rid of that, both of those requirements, by essentially requiring the amount that can be at stake to be aged in the previous epoch of consensus. And then when it comes to actually inferring the total stake, we use Robbins-Monroe stochastic approximator. And so what this is basically the ability to be able to learn a value through a corrupt signal. And in our case, that corrupt signal is the block production rate, right? So if we're seeing many block proposals, that means the difficulty is too easy, and so we can we ramp it up, and the inverse, right? And it turns out in our simulations that we can accurately predict this within a 3% tolerance. Yeah, I know I'm glossing over, yeah, right, so private programmable transactions. Like I said, this is zero cash semantics. So, you know, if you're familiar with Zcash, it's like shielded transactions. In our case, every coin or UTXO has a ledger ID associated with it for a particular zone that it's operating in. And it has programmable spend rules. The main thing is that kind of different here as we've updated the cryptography a little bit. There's basically two proofs. One's a Merkle mountain range and one's an index Merkle tree for both your commitments and nullifiers. This means you don't need to maintain a giant list of serial numbers. I know I kind of glossed over that. If you're more technical, there's a talk that I did at Protocol Berg. There's a QR code where I talk a bit more about the technical details of that if you're interested. So, yeah, we have this basically like the sort of secure root or core. This is kind of like, you know, we conceptualize this as kind of like a UEFI BIOS, where we actually expect most of the transactions to be happening in like what you might consider to be called roll-ups. It's not quite like roll-ups. We call them zones. But they're effectively the same sort of thing, right? You have
In case you were wondering, we are indeed going to that Protocol Berg talk that Jared just mentioned. Following this one, stay tuned. This is Logos Dev Club, Monday, February 23rd, an auspicious day. If this is interesting to you, you see some URLs there scrolling across your screen and fixed, respectively. Roadmap.logos.co. If you're looking to get deeper into the technical objectives and ongoing work, links to all the GitHubs, roadmap.logos.co. Generally, to stay informed and on top of what is happening in the Logos ecosystem, logos.co/take action, take-action. Back to it now as Jared wraps up the higher level overview. We'll zoom into a lower level review following this. Please like, share, subscribe, and turn notifications on wherever you might be watching. And wherever you might be watching, the chat works. If you have any feedback, questions, pointed and critical feedback, all of it is welcome in the chat. Please use it. Mahalo. Back to it now. Jared Hope.
execution that's happening on these other sort of like chains. And they, you know, there's a couple of requirements that we need for another service that allows us to do atomic transactions between zones in a private way. They support blobs, they support inscriptions. Yeah, and it's actually very, like, from our data availability sampling, it's incredibly light to verify any zone, which is important for light clients. Yeah, I mentioned one of I mentioned this already, but like we have an intent-like system that's entirely private. We call it PACs, or private atomic cross-zone transactions. Basically, this allows the aggregation of like partial transactions with hidden inputs and outputs. Only the relative balance plus that equals the fees is revealed. Yeah, and these are all these partials effectively ZK aggregated. And gives you this sort of cross-zone consistency proof that allows for transactions between zones. And the fee capture for the executor can also be in a separate partial. So one of the zones we're working towards having at get-go is a way to kind of interface with account-based models and this sort of private UTXO model. So we've been, one way to think about this is it's kind of like Aztec, but you can do things in a single transaction, whether it's, you know, public to public, private to private, or vice versa. So yeah, it's a state separation architecture. You can basically run smart contracts both in public or private state, or move between them. Yeah, that's pretty much it. I wish I could go into more detail, but yeah. We care about resource-restricted devices a lot. We're very concerned about being able to run this on laptops and particularly on mobile phones, right, or smartphones. So pretty much anyone that's participating in the network is effectively a light client, is basically helping verify whatever zones that they actually care about. Light clients were a by default decision to start with. They have, yeah. So that's it for the sort of blockchain aspects of it, or the multi-chain aspects for it. Who remembers, I mean, you know the Bybit hack, right? Show of hands, Bybit hack? Yeah, okay, cool. Well, for those who didn't, basically you had the continuous integration deployment of Gnosis Safe was compromised by a hacker by leveraging a Safe employee's credentials. No one was aware of the injection. Gnosis Safe basically worked, except for a target attack on a particular group, in this case, Bybit. And this kind of shows the inherent issue of like the client-server models and like why we can't really trust running our front ends on just a website, on a web server. So we've also been working on a decentralized file storage system. It has content hashes that are compatible with IPFS, but it's we disperse the sort of blocks around the entire network to avoid like notions of pinning, or as a result, the inverse of pinning is like censorship, right? We have automatic repair and dispersal. There is a marketplace that we're working on that allows you to collateralize. Yeah, cool, thanks. Yeah, we have Reed-Solomon and Erasure coding. We've been working really hard to try and make this consumer friendly. And we managed to get these sort of proofs down to around 5 minutes with 16 gigabytes of memory, so perfectly adequate on the laptop. And we're working to, we haven't done it yet, so there's still a bit more R&D, but we're working on like oblivious queries. So if you make a query in the network, other participants will not be able to understand, what you're actually querying or the content of it. We also work on open hardware. We're really currently coming out with Keycard Shell. It's a hardware wallet that has a secure enclave on a smart card. The entire thing is completely open source. We implemented a bunch of things. That's pretty much it. I know I've been ranting, I've been going really fast, probably not giving you enough details as much as I would like to give you, but basically what Logos is, it enables you to build private, uncensorable, decentralized applications. So when's all this happening? It's a little bit early for us to be talking about this, but it's been going on for roughly about 5 years. We're still working on it. We believe that we will have our we have specifications, they're not in a single repo yet. They're between teams and internal documents. We're going to be publishing those. All of these protocols exist already in some form. We need to integrate them, and we believe we'll have a testnet out for this sometime next year. But Logos itself is more than just that. We also want to rebuild civil society. We want to bring crypto into the real world. And so we're building out Logos circles where we're actually starting to exercise like practical politics, do community developments, to actually start building out a parallel society or a parallel economy. Yeah. So I also wrote a book on a lot of the sort of motivations and concepts. It's called Farewell to Westphalia. If you go to logos.co/book, there's a PDF you can download. It's CCSA. Logos.co is the website. There's an onion if you're so inclined. But yeah, that's it from me. Thank you.
That is the high-level overview, folks. Now, for those of you that I am sure are thirsty and hungry for a more in-depth and low-level overview, we will get to that now. What you just saw was Jared Hope at the Ethereum Cypherpunk Congress numero dos. in Buenos Aires this past November. We'll now go back in time just a little bit more to Jared's talk at Protokolberg in Germany. I think it was Germany. Almost positive it was Germany. Right around the halfway point of last year. This is a more technical overview. The beginning of the program, if you missed it, we had updates from the Logos Core and Logos Anon-Comms teams, Yuri and Hano, respectively. Go to the beginning of this broadcast if you missed it. Catch it all on YouTube later. This will be our final installment. I'll have some words at the back end of this presentation. Again, if you are so inclined, visit roadmap.logos.co for your technical gateway into all things happening and to find areas and opportunities for you to contribute. Logos testnet v0.1 is imminent, will be coming out very soon. To be in the know, whatever there is to know, logos.co/takeaction is your destination. Roadmap, take action. Take action, roadmap. Uma, Oprah. Oprah, Uma. And if you saw David Letterman hosting the Academy Awards in 1996, you know exactly what I'm talking about. I digress, but that's what I do. We go now to Jared Hope at Protokolberg 2025, covering Cryptarchia, consensus, and blend broadcasting. I will see you on the other side. Use the chat if you have questions.
So today I'm going to talk about two protocols, Cryptarchia Consensus and Blend Broadcasting. One is a private proof of stake consensus algorithm that kind of looks like proof of work actually, and Blend Broadcasting is basically the result of some of the issues we found in securing validators on the network layer. So here's a question. Are you going to submit a block proposal or relay a transaction if it meant that a government's going to kick down your door and arrest you and put you in jail, right? It's not an unreasonable question to ask these days due to recent events over the past couple of years or so. That's certainly been the case. And people today are going to jail for social media posts, which are a lot less benign than financial transactions. According to MevWatch at least, even over the past 30 days, that 42% of the people are considering that kind of course of action of self-censoring. So we want to prevent this. And the reason for doing that is because if we care about impartiality or credible neutrality of our networks, then we need to be able to secure our validators. We need to protect the people who are actually making these networks run, right? And if we don't do that, then we basically undermine the entire value of crypto at all, right? You might as well just use a regular database and even just the regular banking system. So this can basically be distilled down into two properties that we want to address. One is this idea of linkability, which is understanding which node had actually proposed a given block. The more stake you have, the more likely it is you are going to win, and therefore you can become more transparent on the network. And stake inference, right? Basically the same sort of idea. But it's related to how much stake you actually have in the consensus. Because you want to target the big ones. So we want to make this very, very difficult or more costly for an adversary to learn. So when we think about a blockchain network in particular, you can kind of split it up into 4 domains of concern. You have the sort of network layer, so P2P communications, how are these nodes talking to each other? We'll address this with blend broadcasting. We're talking about the consensus layer. Obviously, this is the, where you're actually securing the network, proposing blocks, and there's, stake or, mining, however you're securing the network behind it. Then there's like the transaction system, so what's happening on the ledger. We'll talk a little bit about that. The mempool is also another domain of concern, but that's out of scope for this talk. We're really only talking about the first two in this talk. So even though I said that, we do need to touch on the ledger just very quickly. Basically, we're talking about zero cache semantics here. If you're not familiar with what zero cache is, it's a UTXO privacy preserving protocol. If you know the Zcash project, shielded transactions, you know what I'm talking about, right? In Nomos, however, we use UTXOs, but much more like a sort of general data model for a thin execution layer on top of it. And we are tracking not just one ledger, but we're tracking multiple ledgers. So in Nomos notes, we actually change the semantics. We keep the semantics, but we change it a little bit. We update the cryptography. So if you're not familiar with zero cache, basically what the ledger is tracking is two proofs, two Merkle roots, right? One is commitments or minted notes. So like these are the notes that you can spend. And another proof, which is, in our case, nullifiers, or the notes that have been spent, right? So in something like Zcash, you would have this notion of serial numbers that get revealed, and you have this sort of long, linear, ever-growing set of serial numbers that you have to track. We actually compress that inside an index Merkle tree, right? So not even the serial numbers get revealed in this. Doesn't really matter. Basically, minted notes, spent notes. And if you can produce a proof that says that my note is in the set of minted notes, and I know my secret key, and it is not in the set of spent notes, then I'm allowed to spend. Okay. So we want to get to consensus. We want to get to that party, but first we need to bootstrap. We need to get into the up to date to get to that party, right? So there's a bit of a problem in synchronizing from scratch, right? It's like, okay, let's say a stranger shows you two immaculate blockchains. They look identical, but if you choose the wrong one, you're going to get rugged, right? You don't want that. So Cryptarchia actually belongs in the sort of Ouroboros family of consensus algorithms, and specifically, we are borrowing a lot of semantics from Crypsinus, and they take their fork choice rules from Ouroboros Genesis and Prouse. So when you first bootstrap into the network, you're basically getting all these blocks, you're going along, but when you find a fault or a fork, you're basically choosing the densest out of a certain set window in like an epoch or two, which I'll get to in a second, right? And the reason for that is because it's going to be much, much more difficult, or they prove that it's much, much more difficult for an attacker to be able to create a denser blockchain against a whole bunch of honest nodes that are proposing blocks in a certain time period. And then once you're fully synchronized, you kind of fall back to a longest chain sort of fork choice rule within like a certain, not going all the way back into infinity, but just to a certain interval. So once you're synchronized, basically, you will start to notice how the game is being played. And so in Cryptarchia and in this sort of family of consensus algorithms, time is split into these epochs, right? And in every epoch, you have a series of slots, right? These are all potential block allocations. A slot is basically every second you can think of, right? And we target a block production rate parameterized in Cryptarchia of roughly one block out of every 30 seconds, 30 slots. But within an epoch, there's actually sort of three phases that are going on beyond the normal sort of block production, like growing the chain, right? And so in the first phase is really about coming to consensus on what the sort of validator set is, right? However, in our case, we can't know the validators and we can't know the total amount of stake.
So we're actually coming to consensus. What we're actually doing is we're using at least one epoch, so the first block and the last epoch's sort of commitments in the sort of transaction system, right? So that spent notes and minted notes. And so that becomes this sort of aged notes idea, right? And so by then, by the end of the first phase, everyone should have confidence, at least the honest nodes, what that commitment set is. Then we'll basically continue to accumulate more information, and at the end of the phase 2, we'll have our epoch or our randomness revealed at that point, along with a total stake estimate, and we'll get to that in a minute. And then the phase 3 is just making sure that's deep enough for honest nodes for the next epoch. So by the end of that finalization, end of the epoch, we'll have these sort of 3 main constants, right? So the C lead is that sort of aged note commitments that I talked about, at least an epoch old. We'll know the sort of randomness that has to come after the sort of leadership eligibility to prevent grinding attacks. And then we have our sort of total stake or our difficulty, our
Moo, what do you mean? Audio from a different source. If you're still there. Should be working. It should be working.
and third stake. And once we have all of those constants, we can finally play the game, right? We can see if we can roll the dice, and we can see if we actually are able to propose a block. And the logic, at face value is pretty simple, right? So basically you need to get some randomness, that's the epoch, and then we check that randomness against our total stake, our stake in the network versus the total stake. And if it's the randomness is less, we get to propose a block. That's essentially what the game is. Yeah, so we know the randomness, we know our total stake, but other people don't, and we don't know theirs. So that's a problem. And not only that, because we don't know theirs, they don't know ours, we also don't really know what the total stake is, right? So how do we figure that out, right? And what's kind of interesting is this starts to look a lot more like Bitcoin's difficulty adjustment. So back in the sort of 50s, Robbins-Monroe proved that you could learn unknown value through a corrupt or noisy signal. And this basically gave birth to a whole class of algorithms called stochastic approximation expressions. And so basically, this is very similar. If you're familiar with Bitcoin's difficulty adjustment, it's very similar to this. And this actually starts to look a bit more, even though it's proof of stake, it actually looks a little bit more like proof of work, because you don't know how much the hash rate is out there or the amount of stake is out there. And you're having to adjust. So what is this noisy signal that we're looking at? Well, what we're actually doing is seeing how many proofs of leadership, how many blocks are being proposed within a time window, within those sort of first 2 phases of an epoch. And by doing that, we're able to essentially compare that against our sort of ideal sort of rate of block production that we want, right? Here is that 1/30 that I was talking about. That's what the natural log is there. That sort of 1 minus f is. And then we just basically, do signal up, signal down, depending on the learning rate. And it turns out that this actually works. And the estimator, at worst case, has a sort of 3% difference or error rate through this noisy signal. You basically treat this as Bernoulli trials, and you'll find that out. We also simulated this doing large mass approximation over 70 epochs. even in the event that you had like a centralized stake, I mean, which is super fascinating. That was one of the points that I wanted to bring up here, but I've lost it. So, even though that sort of one-liner logic of what the proof of leadership is doing, the actual proof is a lot more involved, right? Don't have to really worry about too much of this. I think, the condition 2 is just basically that sort of leadership eligibility, but also showing that it hasn't been spent in that time either. Conditions 3 to 5 are essentially that logic, checking the randomness against the sort of your relative stake. The difference here, though, is that to fit this in a circuit, we have to basically do a first and second order Taylor expansion to approximate the threshold. Otherwise, it's not possible. And if we can do all of this, if we can create a proof like this, we can have basically an authorization that says, yes, this block is, I have the right to propose this block. You don't know anything else about me, and do with it what you will. There is one extra thing that we have to take care of, which is this sort of condition 6 and 7, which is one other issue against an adversary. So this comes from this construction comes from Chrysinus. The basic idea is that an adversary might be able to find your computer, right, and that you used to propose blocks with in the past. And if they can, they'll be able to take your keys and they may be able to recreate those blocks, right? And so that's a problem when you come back to this sort of densest fork choice rule, right? You might be able to create, if you can do this enough, you might be able to create a dense enough blockchain to be able to change the course of history. So what we do is we basically take the, we create a Merkle tree and use the root as the sort of secret key that controls the stake. And within that Merkle tree, we basically generate a whole bunch of key pairs and put them into that. And within the proof, we're showing that we know a path in that Merkle tree to that particular key pair, and we, and we've signed it. And it's and then basically it's up to the honest nodes to be able to delete those keys as they go along, right? Okay, great. So you have this block proposal. You're able to propose a block. No one's going to know that how much stake you have or who you are, but you now have a new problem. And then you're going to be able to, how am I doing? Yeah, you're going to be able to send this onto the network, right? And this is basically how every blockchain, not every, but vast majority of blockchains work, is they'll broadcast this block proposal to the network. Now, what we're going to be doing if my explanation sucks is just imagine a game of Pass the Parcel. Show of hands who's played Pass the Parcel as a child. Not too many people, interesting. Okay, well, that analogy sucks. Basically, it's, if you can imagine like a toy or a gift, as you get as a present, but every single layer, it's wrapped multiple times, right? And usually there's a piece of candy between each single layer. And it's like kind of like musical chairs, like you basically run the gift around the group, and when the music stops or whatever, someone gets to open it, and they get the candy, and then they pass it on, right? So there's like this sort of onion wrapping thing. The dad there, who has a very stern look, he's probably had a really bad day, is our adversary. He probably controls 2 kids and can strike the fear into everyone else, right? Okay. So you might be thinking, well, why not just use a mixed net, right? Or why not use an onion routing? I can be covered under that. Surely that's what these anonymizing communication networks do. And if you're doing a transaction, that's a reasonable assumption. If you're even doing consensus and you're the only one who has that idea, that's also good. But what if you're not the only one? What if it's 10 people, 100 people, 1,000 validators, all participating in consensus? Well, that's where both onion routing and mixed nets start to kind of start breaking down. And the reason for that is because of the nature of this traffic. So if you think about it, right, like this kind of traffic is running on a synchronized clock where they're basically producing blocks every, potentially every second, but, ideally parameterized to, in our case, one every 30 seconds. And so they're creating this sort of like wall of traffic that's going on a heartbeat, that's going boom, boom, boom. They're synchronized senders. And that's a huge problem because mixed nets rely on exponential delay for their anonymity, which means that as you have this kind of wall of traffic flowing through it, the delay will go beyond your block production rate, which is a problem for safety and liveness. And onion routing is notoriously bad for, is very well known, weak to sort of traffic correlation attacks. So we actually need like a Goldilocks protocol, something that's not too hot, not too cold, right? And so we need to raise this cost of linkability, like this time to inference, while maintaining a maximum delay in the network of lower than our block production rate. We target 20 seconds. We now need to allow for network churn. We need to minimize message censorship. We need to incentivize cover traffic on a 1 second schedule. We need to mix messages. We need to minimize spam as well. And we need to use minimal bandwidth, right? So it's actually a very challenging problem. And so to answer this problem, we've come up with this notion called blend broadcasting. And you can imagine it's something like a hybrid between all of these. It's a sort of mixed net flooding gossip. It has these sort of 5 linear paths of 3-hop sort of multicast circuits that are created in it. It has geometric delays, pulled queues, and it has that cover traffic, right? So here you see this sort of blue circle, that's a block proposer, let's say. And it's broadcasting down 5 linear paths of 3 hops. That is not the peering degree. That is, the peering is done on the sort of flooding notion. The linear paths are kind of emergent through the mixing. And ultimately, you're expecting a terminus at the sort of broadcast for the entire blockchain consensus algorithm. Yeah. So why blend? Well, we don't assume a global passive adversary because that's kind of like, it's a very weak adversary actually, and it's also unrealistic from a global standpoint. So we assume much more a partial, so active adversary. In our case, we assume the network is 10% adversarial nodes and 10% faulty nodes, and we parameterized the network with these sort of 5 linear paths of 3 hops each, under peering degree of 4. And with these assumptions, we believe that we can raise the time to infer by 300 times for a 50% confidence in a proposal by an adversary. The difference between having this and not having this is having the government kick down your door in 12 days versus 10 years. Yeah, so I'm running out of time. Never mind. So basically how this works is you have to register with a directory initially. This is backed by stake. We're not going to get into this. The main thing here is the provider ID, because this is going to be used as a Diffie-Hellman to open up messages addressed to you. Now, like, we're trying to do 2 things. We're trying to create a lot of traffic at the same time, but we want to prevent bandwidth use, and so we need to have it spam rate limited. And so we actually need every message to be uniquely identified for a session or for the epoch. And we also restrict how many nodes so how many messages a node can make, right? So basically what happens at the beginning of every epoch or its session is you have to basically create a whole bunch of ephemeral keys up to your allocation, which is a protocol parameter for the session. And you have to create proofs for all of them. So this one basically is a ticket that says, yes, I'm part of this registry, and I've generated this public key, right? And it's under the quota limits. And you also have to do the same thing, but with a proof of leadership, where you basically say that this is a proof of leadership. So this is a separate parameter, so you can still allow for covered traffic and valid proof of leaderships to come through. And then you wrap both of those proofs into a proof of quota, right? So this is kind of like the first part of a candy inside the parser game, right? So you open off a sort of wrapper, and you'll see candy, or a bit of this candy. I'm running out of time. Huge problem. I was too ambitious. I apologize. So basically, when we were ready to send a message, we have to sample 15 nodes to create these 5 linear paths through the network. We have to generate what's called a proof of selection here, which basically proves that the public key is mapping to the index that you've chosen, right? So like when you're taking off a wrapper, you get to look at it, and like, you know, if you can take off the wrapper, it's because the encryption worked, and then if you look at it, this will tell you whether it was actually designed for you to broadcast or not, right, onto the public channel. And if you collect both of those, and then you can use those for rewards, which we won't talk about in this talk. And then you use that to look up the provider ID to set up a Diffie-Hellman to encrypt the payload. I'm basically out of time. Message encapsulation is basically like Sphinx, if you're familiar with it, except, you know, we add some of the proof of quota to this, and the private header is basically the same, but it has this proof of selection, sort of second part of the candy associated with it. So yeah, through doing that, we incentivize people to send message or relay messages within the network, but we also restrict people from sending any more messages than they're allowed to. Basically out of time here, like I think when when a node receives a message, just look at the last 2 lines. You actually immediately relay everything that you get, and then you put it into a processing queue, right? And the reason for that is to prevent any timing attacks. So you're always kind of flooding. Once you do that, you know, I've already kind of walked through this. You basically get this blending token, which is the proof of quota and the proof of selection, so you can use that for reward proof later on. Yeah, so every round, that's every sort of slot activation, right? So every 1 second, but it's not every 1 second that you're doing your broadcasting on the mixing side. It's a little bit of jiggle associated with it. So yeah, you're also running this cover scheduler that's basically injecting more cover messages into the queue if you have a budget. Yeah, and that's basically it. I'm sorry I had to speed through some of that towards the end there. There are some limitations, again, so the mempool is a huge problem as well, susceptible to tagging attacks. So an adversary could be able to specifically target certain nodes with tagged blocks or, you know, transactions or whatever, and see how it propagates to the network to be able to identify them. The other thing is that even though we're raising the confidence for block proposals or leaders to be able to emit blocks here, leaders can still self-censor themselves for whatever reason, right? And like an ideal here is that we could force a leader to include transactions, right? So we're working on these. If you're interested in working on these, please reach out to me. And the other thing we haven't covered in this talk is edge node anonymity, right? So like if you're not part of this sort of validator set, how are you anonymous? And for that, we have 2 answers. We work on the WACU protocol, which is ephemeral peer-to-peer messaging, and we worked on libp2p mix specification, which we apply to our protocols as well. So yeah, if you have any questions, feedback, hit me up on X. I'm sorry you can't ask questions today. Bunch of URLs.
And there it is, folks. Haha. Oh, that's all good, Moo. Man, I was like, oh my gosh, what has been playing? Thank you for the feedback. I appreciate it. It's good to see people ingesting and taking it in. I think we've set our Logos Dev Club record here for time live. Actually, I take that back. I think the Spritz.chat broadcast was much longer. Folks, thank you for watching. Thank you for those of you who are interacting in the chat. We have covered a lot today. The very top of the program featured updates from Logos Core, Yuri, non-coms, and Hano. We saw Jared's talk from the Ethereum Cypherpunk Congress in Buenos Aires this past November, which was a more high-level overview of the what and why of Logos. What we just saw was Jared's talk from Protocolberg from July of this year, I believe, which is a lower level, more technical zoom into the architecture and construction of the Logos protocols. There is a lot, to be aware of. You have time to consume it, but you should start now if you are interested, if you are looking to make technical contributions or understand better what Logos is building and how you can implement it. Roadmap.logos.co will take you to all of the components within Logos, what is happening technically there, what the milestones are, and where the code lives in GitHub. And that should be adequate for you to get started or to at least reach out with more questions. Logos.co/take action is where everyone should go to sign up for updates, to be kept informed on anything that there is to know as it comes up. Those are your 2 locations. And last but not least is Parallel Society Festival happening in Lisbon, the 6th and 7th of March. ps.logos.co, and I will show you that URL thusly. There it is. Right there. ps.logos.co. Get your tickets now, especially if you're in the Iberian area or anywhere. Get your tickets and we'll see you in Lisbon. Tomorrow is the Logos Circles Online X Space. Follow Logos_network, which I'm sure you already are. Tune in. Those spaces on Tuesdays and Thursdays are hosted by Sterlin, the brave, the loquacious, the eloquent, and elegant. Elegant and eloquent is Sterlin. Those are the Tuesday and Thursday spaces on X. This Wednesday, we will have the Logos weekly update. That is a more technical leaning space broadcast. We also have the IFT research call this Wednesday. All that is to say, there's a lot going on. There's plenty to be kept abreast of. Logos.co/take action. ps.logos.co for Parallel Society. I will see you every day this week. And until next time, as always, todo es mentira. Desde el mundo, todo es mentira. La verdad, the world is a lie. That lie is the truth. This has been Logos Dev Club. See you tomorrow.
In cyberspace, no one is free until we are all free. Self-sovereign, self-sovereign. Privacy is not secrecy. It is a fundamental right. Your life is as private as you want it to be.